Hello everyone, welcome to this session. Our chapter is waves. Uh, so far in our previous video, we covered about the propagation of the waves. So today, let's discuss about the frequency, speed, and the wavelength of a wave. So specifically, we will discuss the relationship between these three: the frequency, speed, and the wavelength of a wave. Starting by the frequency of a wave. Simply, a frequency of a wave is just the inversely proportional of the wavelength. So the frequency of the wave is inversely proportional to its wavelength, and the speed of the wave is always constant in that kind of a matter. Now that can be displayed in this kind of equation: F is equal to V upon I. That is the speed also of a wave can be expressed just as the product of the frequency and the wavelength. So that's how these three they can be related. Now that is the mathematical equation that can express that kind of a thing, that V is equal to F times I. That is speed of the wave is expressed also in meters per second. Now, period of a wave, this is just the time taken by a wave to complete one oscillation. So that's the meaning of a period of a wave. It's just the kind of a time that is taken just to complete one oscillation. And the frequency is just the reciprocal of the period. Mathematically, it can be shown as you can see here. This is the equation where V equals to F times lambda, whereby V is just the speed of the wave, lambda is the wavelength, and F is the frequency. Now, let's talk about the refractive index of a medium. Refractive index is just known as the ratio of the velocity of a wave in air, abbreviated as VA, to its velocity in medium, that is Vm. So that's how you can define the refractive index. As you can see, this equation N is equal to VA upon Vm, so that's the refractive index. And the refractive index, it can also be obtained as the ratio of the sine of the angle of the incidence, that is sine I, to the sine of the angle of the refraction, that is sine R. So that's also how you can obtain the refractive index. The speed of the wave usually depends on the medium through which it transfers or through which it is traverses. Now, changing the medium also means changing the speed. Now, absolute refractive index is equal to V in a vacuum upon V that can be in given medium. Now, refractive index of a material is just kind of a measure of the change in speed of light as it passes from a vacuum or air as an approximation into the material, and it can be shown with this kind of equation abbreviated as N equals to V1 upon V2. Now, refractive index of a medium, in the equation above that we've seen that V1, that can be known as the speed of light in a vacuum. Now, the bigger the refractive index, the slower the light travels in that material. This means that the smaller V2 is. So that's how you can see the relation there. Now, the light of frequency, that is 4.6 times 10 raised to 14 hertz, travels at a speed of just 1.24 at 10 raised to 8 ms minus 1 in diamond. Now, from there, that we can use it for this example. Calculate the refractive index of the diamond for this color of light. So that information we had before. So this we use to calculate through the example. Now, solution, we know that from the given data, we know that V in diamond is equal to 1 times 2.4 times 10 raised to 8 m per square. Now, C that is given from the data sheet, we know equals to 3 times 10 raised to 8 m per second. Now, from there, from the equation, we know that refractive index equals to V1 upon V2. Easily, you can calculate that the refractive index in diamond is equal to 3 times 10 raised to 8 upon 1 times 24 times 10 raised to 8. We get the answer, that is 2.42. So refractive index of diamond for this color of light is just 2.42. So that's all I have for this session. Hope that's clear, everyone. We've seen a simple relation between the frequency, speed, and the wavelength. Then we've discussed the refractive index, how you can obtain the refractive index of a material, and we've seen a simple example. Now you can do that. So that's clear, and thank you.